Hi, my name is Justin Tylis. Welcome to the Demetrix Rare Access Series. Today I'm joined by Anna Lee, scientist in our DNA operations team. Welcome, Anna. Thanks for joining us.
Hi, Justin. Thank you for having me.
So, Anna, would you mind just letting people know your background and current role at Demetrix?
Sure. My background is in synthetic biology, and I was very interested in engineer bacterial behaviors and using computational models for optimizing and predicting their behaviors. After my studies, I moved to the Bay Area, and I've been working in the biotech industry for about 3 years now. Currently, as a scientist in DNA operations team, I'm responsible for maintaining, troubleshooting, and optimizing our automated R&D pipelines.
Great. And so, what are some of the main goals and objectives for your team in DNA operations?
We strive to make new strain development process both time and cost efficient. To do so, the main goal of our team is to make R&D activities more efficient and higher throughput by providing the tools. For that, we have multiple pipelines that support R&D activities at the Demetrix, and we also actively communicate with other teams to find different ways to help and to provide new tools as it's necessary. We aim to ensure that each process is robust and scalable so that we can support the increase in R&D activities as the Demetrix grow.
And so, what are some of these different pipelines that you're currently working on?
We have three main pipelines. Each one has a DNA sequencing component, but each one is also very unique. We have a DNA sequencing pipeline, a colony PCR sequencing pipeline, and a whole genome sequencing pipeline. The first pipeline is used for high throughput DNA building. To continuously build and test new strains, we need to build a large number of synthetic DNA parts with different promoters, genes, and so on. Our DNA building pipeline integrates software tools and automation so that the process is streamlined, and we can build large number of DNA parts in a relatively short period of time. Newly engineered strains using the synthetic DNA parts can be diagnosed with another pipeline, which is called colony PCR sequencing pipeline. It allows quick assessment on whether intended genetic modification was successful. We implemented a unique barcoding and design strategy so that we can have a standardized method for quickly assessing the new strains. When there are strains of a particular interest from screening process, either from microfermentation or large-scale fermentation, we use whole genome sequencing to determine the DNA sequences of our strain's genome. By checking the strains with whole genome sequencing, scientists can get the full picture about the strain, detect any intended or unintended mutations, and also find correlations between the strain behaviors and their genetic background.
Wow, so it certainly seems like you guys are working on a lot of stuff right now.
Yeah.
Awesome. And so, so lastly, just wrapping it up here, what can people expect from the DNA operations team in this year into next year?
Yes, as we are growing rapidly, we want to make sure that we have capacity to support the increased demand in R&D activities. We continuously look for ways to improve each pipeline, make it more accurate, and make it higher throughput so that we can make our research process more efficient.
Awesome. Thank you, Anna. So this is our next episode of the Demetrix Rare Access Series. My name is Justin, and thank you for joining us, Anna.
Thank you, Justin.